Oh. I didn't realize I did that.
All right, this is going to be a really short video because I just want to make a couple remarks on like the last page, which is let's look at 26. So you have a stone of mass M attached to a rope of length L. It's sliding along a frictionless floor in a circular path at a constant speed. And the diagram that you're given is just an overhead view. So can we all visualize that? It's being swung around in a horizontal plane. And it's just asking us to write, we've done this question before we knew about terms like omega. So the angular velocity of the system is omega. Does that, first of all, does that make sense? Do you understand why the rope and the ball both have the same omega?
Yeah.
For sure? And do we understand why or how? So like, if you picked a point, this point on the rope has a smaller velocity than this point, but they have the same omega. Okay. Good. So we want an equation for the tension in the rope in terms of using omega instead of v. So it's actually a very easy question if you can recall how you do it with v. Does anyone remember what the answer is going to be for? So if we allow ourselves to use v, what will be the tension in the rope? For $1 million. Does anyone remember? No? Does that ring a bell?
Yeah.
It's centripetal force. Now, of course, this is, well, I mean, there's a preliminary step here generally, which is that this really just says F equals ma. F net equals ma. Well, then, because then you go, well, what's the net force? The net force really is on this ball is just the tension in the rope. That's what's providing, that's the only force that's relevant here. And then the mass is the mass, and then the acceleration, this term is centripetal acceleration. Okay, so something's moving in a circle at constant speed, its acceleration has to be v squared over r. So who's got an idea for, the question is saying, I don't want v in there, right? I want there to be just an omega. What should I do? Yes, Caleb.
Replace v with omega times the radius.
Very good. So this is a really, I've been saying it a lot, right? This is a really valuable formula because it's going to allow us in a lot of different cases to take something we know about physics and then now look at it in terms of like omega or alpha instead. So I'm going to do that substitution. So it's going to be the tension is the mass times omega r squared. We all understand that substitution? So what's this going to look like? On top, we're going to have omega squared times r squared. And on bottom, we have r. So what's going to happen to those?
Is this going to turn to omega squared times r?
So you're going to have mass times omega squared times r. And then remember what Mr. Actually would say. We've done this game.
Is the radius.
Yeah, he'd say, actually, this problem said the rope, there's no R in here. We all know what we're talking about, but actually, we should use L. The answer to this question really should be the tension is the mass times omega squared times the length of the rope. And there you go. How do we feel about that?
Neat formula.
Yeah, isn't that nice? Nice and tidy.
Yeah, it was kind of close when I just threw them all together haphazardly.
So, 27. What's going to happen there? This is another question we've done before.
We have the-
You've got a hockey puck on a circular platform. So, I mean, I could pretty much use the same picture. A circular platform is spinning around, and there's a hockey puck on the platform. So, why might the hockey puck slide off? There's kind of there's two reasons it might slide off.
Is it if the centripetal force exceeds the friction force?
That sums it all up right there. Yeah, that's a good answer. So why might that happen? Well, maybe the disk is spinning really fast. So really big omega could cause the thing to slip off. Or maybe it's just not very much friction. Maybe the puck is made of a slippery material. Maybe the disk is made of Teflon, right? You understand that?
Yes.
So your equation, you're going to end up like relating exactly what Colin said. You're gonna look at same setup pretty much. The only difference is it's not tension anymore, is it? This is going to be now. What's the expression for friction force?
UMG.
Huh?
UMG.
Mu times mg, right? So this is going to be mu times mg. This is going to be mv squared over r, and then you're going to do the exact same substitution that Caleb said a minute ago, and you're going to relate all those terms. So that's more like, I guess 28 is the general case, and then 27 you're going to involve the numbers and actually solve what's up, Adrian.
So would you just take that as mu mg is equal to the m times omega squared L?
You can do that, yeah. You can maybe jump straight to that. That's a good point. All righty. That was it for today.